Welcome back to Cloud 42, I'm James. Today we are still working on the ToolPost grinder. This is going to be part 7, and as usual there's a link to the previous videos down in the description. Today we're going to work on the motor pulley. It's very similar to the spindle pulley that we made last time, but the dimensions are a little bit different. Let's take a look. This is the motor pulley. You can see it's very similar to the spindle pulley, it's just a much larger diameter and a much smaller hub. The motor shaft is only 8 millimeters, so we need to bore that a lot smaller, and we'll see if we can get in there with the high-speed steel boring bar that I have to make sure that's concentric. I think we're gonna do the same thing. We're gonna try to run this all in one setup. There's one thing that I wanna change on this. I think I'm gonna add another 100 thousandths to the hub, and the reason for that is after seeing how the spindle pulley fit on the spindle, and I was getting about 4 thousandths of run out all the way out at the edge. I just want to make sure that we get the best alignment possible because this pulley is much longer, so it's going to be more susceptible to running out if there's any issue with squareness in the mount. So I'll add an extra 100 thousandths when I machine it here and leave the screw set where it is, which will put the screw hole then back towards the center of the bore, and hopefully that'll give us a little better alignment. Again, since it's all in one setup, it should all be concentric, and we'll see how that turns out. I've got a piece of aluminum, 1 inch thick, piece of 3 1/4 inch round, and let's go over the lathe, chuck it up, and make a pulley. Okay, now to mount the workpiece in the lathe, I'm not going to be able to do it with the outside jaws. I need the inside jaws, so first thing is to swap those out. Now it's real easy when you're doing this to drop a jaw, so what I always do is set it up so one jaw is on the bottom and the other two are facing up. Then I'll hold on to the bottom jaw, and as I back it out, I don't drop one then. Let me take the spider off. Let's get the outside jaws. See, these are numbered. It's 1, 2, 3. Okay. There's the first one captured. There's the end of the scroll. And here's the third one. Okay, now because I'm going to make this a little bit thicker, I need this spaced out slightly. I don't want to run out of space here, but because I'm trying to use the last step on the jaw, the center is too close to use the spider. Spider will not physically fit between the jaws. So instead, I'm going to use a couple of parallels to space this off. And I will just stick them temporarily in here. Let me turn it this direction so the bottom parallel will stay on its own, and I can put the top one in and hold it while I tighten this down. I don't usually like doing this because it's just so easy to lose your focus for a minute. The phone rings, somebody walks in behind you, something happens, and you leave one of these sitting in there and then spin the lathe up and they fly out. You don't want that to happen. If you're wearing eye protection and you're standing clear when you spin it up, you won't get hurt, but boy, it is scary. And everybody, regardless of what they tell you, has made a dumb mistake like that. Now I'm only holding this by a little bit, so I'm going to get it nice and tight, let those steel jaws dig into the aluminum. Now, let's see what that looks like spinning. Okay, that front face is running out quite a bit, but that's just because it's not parallel to the back face. Okay, Let's get a turning tool, get that faced off. Oh, not quite cleaned up, getting close. Now we're not totally cleaned up on the outside, but that material is going to go away, so we can go ahead and start drilling. Okay, we're going to 315 thousandths, and this is about a 270 thousandths drill. This is actually about the same length and size of the spotting drill I usually use, so I'm just going to skip the spotting this time. And this time, because of the way we have this mounted and the way we're holding it and have space behind it, I can go all the way through without any concern. And there we are, through. Okay, let's grab a boring bar and just clean that up and then try to figure out about where we are. Okay, we are going to pass. Good. See, how deep can I actually go with this before I hit something? Oh yeah, I can go all the way through. Okay, so we're right about 19/64ths, which means that right now we are right about 292. And we are headed for 315. Which means we need to take 11 off of each side. I'm going to take 8, I think, and then see if we can get the telescoping gauge in there. No, we really can't. Okay. Let's take a caliper dimension on that. It says we're about 305. Okay. And if we're trying to get to 315, it means we need to take another 10. I am just going to take 3, which will give us 6, and then let's see where that gets us. So close. Okay, so that says we're about 314 and a half. Let me grab the motor here, which is, of course, has the 315 shaft on it. And it's not wanting to start yet. I'm just going to make a spring pass just to make sure we don't have any pressure still on the tool. And try the fit again. There we go. Wow, okay. I'd prefer it be a little tighter, but this is the piece of stock. We'll just see how it runs when it's done. Okay, so that's the bore complete. We're within a half a thou probably. Again, not having a bore gauge that will fit that. Maybe. Let's see what that says. Maybe inside the spherical points of these things. Looks like we're about 315.8. I can live with that. It's actually closer than I expected to get. Okay, next step is going to be to turn back the step in this. And on the drawings, that step is, so it looks like it needs to be 415 thousandths deep. Now that's of course adding 100 thousandths to what was on the plan. And the center diameter of that needs to be 709. Let's start though by turning the outside diameter of this as far back as we can. And outside diameter needs to be 3,055. Let's go in here and set up a dial indicator so we don't crash our tool. That's about as close as I dare go. So we'll set a 0 there. And put a mark there as well. Let's try to get this cleaned up. Still not cleaning up. Nope, it's still not cleaning up. Okay. There we go, that looks better. Okay, let's see what that is. I'm gonna need a 4-inch micrometer here. Looks like we are at 3,210. So we need to take 77 off each side. So let's take 2 passes of 30 and then take whatever's left. Make sure my 0 is good. Here's 30. Take another 30 now. Taking this, trying to break these chips off. These heavy ones are pretty nasty. That at all. You take 5 off and just clean it up so I get a good dimension. maybe 2. See if this cleans it up. Yeah, there we go. Okay. Stringy, stringy. Okay, let's see where we are. Looks like 9 less than 100, so 91. So 3091, and we're looking for 3055. Which means we need to take 18 thousandths off of each side. And that sounds about right. So let's go ahead and take 10, 18. Let's just take the 18 and call it good. Actually, you know what? I'm going to take 10 just so the chips will be finer. And it'll also give us a chance to do one more measurement. Okay, it looks like 3.069. That looks about right. 7th out to go, off of each side. Okay, let's see where we landed. Here we go. 3055 and 7/10. Good enough for me. And the finish is good enough. Not great, good enough. Okay. So now let's set a 0 here. I just got the tool touching lightly. Now we need to go in 415 thousandths. I'm just looking at the drawing. Yes, 415 thousandths. 1, 2, 3, 4, 15. This is where we're going to want the 0. Right about there. So I'm just going to re-zero here. So this is the back of the hub. Okay. So right there is where we're trying to go. And I'm going to pull about 10 thousandths back from that and make a mark. Okay, now we got a lot of material to remove here. And I'm going to try to stay about 10 thousandths shy of the bottom. Okay. take 50 thousandths at a time. In fact, I'm going to take a little bit bigger chip here, see if maybe we can get some of these to break. Okay, so this is the feed I'm taking up to 6 thousandths per pass. We'll see what a 50 thousandths depth of cut does here. No! A little bit less. That'll be okay. Take another 50. And another 50. Another 50. Okay, well, we're getting down close to the diameter here, and let me grab a caliper. Caliper dimension should be fine for this. And let's see where we are. It's supposed to be 709. And it looks like we are at 937. Which means we need to take 114 off of each side. And I'm just going to do that directly because, again, the dimension on this is not critical. Here's 30. This will be 60. This will be 90. $100, $110. Let's do $110 so we can just take 4 on the last pass. As long as we're going to make one more pass, we might as well measure again, see where we are. Okay, we're headed for 709. And it looks like we're at 718, which means we need to take 4.5 off of each side. Okay, now this time we're going to go all the way into the actual 0. And then we're going to back face the part. And that's proving messy. Okay, let's take a facing cut, not all the way to 0, and leave just 5 thousandths. will go all the way to 0. And back face. And there we are. That is the step in the pulley. Oh, that is gorgeous. Look at that. Now it's got fingerprints on it. It's not as gorgeous. Oh, very happy with that. Okay. Curious where we ended up. Looks like 710. And that's close enough to 709 for me. Okay, next step is going to be the grooves in the pulley. Now, we got a tiny bit of chatter on the small pulley, so I think we need to slow this one down because it's quite a lot bigger. This is about 3 inches. If I look at wrought aluminum with high-speed steel, should be going 5 to 600, and at 3 inches, 5 to 600 feet per minute is going to be around 720 RPM. That should be fine. So let me slow this down. There, this should be ideal speed for high-speed steel. And if it chatters, we'll take it down even further. Okay, so first thing I need to do is try to line this up with the edge. This is the form tool. Okay, that looks about right to me. I'm bumping my head on the camera, so you all get to go for a ride. That'll be perfect. Now I'm just going to set a 0 with the tool right at that edge. Now, I'm going to do a little bit of checking here because ultimately the second groove has to be 163 in. So let's make sure I can clear that when that comes. 160, there's 165. Yeah, and we'll clear easily. Okay, first groove needs to be at 71 thousandths. There's a 0. And that's 71 thousandths. So let me lock the carriage. And we know from the last pulley that that's going to be a direct infeed of 90 thou. So let's set our 0. Let's touch off. Okay, that's the touch off. Get a little cutting oil here, and let's just take it in 90 thousandths. 20, 30, 40, 50, 60. $65, $70, $75, $80, $85, $90. Let it dwell. That's great. Okay, there's our 90 thousandths. We might as well take the other one to the same dimension. Unlock this, and it needs to go into 163. So there's 100, 61 to There's 163. And this one needs to go in the same 90 thousandths. That 0 looks good. Okay, 90 thousandths. There's 10, 20, 30, 40, 50, 60, and that's cleared out. Clear the chips. $70, $80, $90. Just let it dwell and straight. And then pull out. Okay. That looks about right. Let me clear this out. Let's grab the thread wires and test it. Okay. O63s. Here's a pair of O63 wires. I'll just measure one of these since we know they're the same. Okay. See what we've got. Looks like we are at 3078. Let's see what the print says. Print says we need to be at 3082, so we're within 2 thousandths per side. I'm going to call that good. Maybe it's the higher speed or it's the different position of the compound or the cross slide made it stiffer and made it bite a little bit deeper. Maybe I scraped it a little longer, I'm not sure. Let's take another measurement there and see what that says. This is the other groove. This is 3077. So just about the same, within a thou. So it is slightly undersized by about 4 thousandths on the diameter, 2 thousandths on the radius. And the only difference that that's going to make at that kind of level is just going to be an unmeasurable difference in the belt ratio. So that is going to be perfect. Now, let me grab a file. Let's clean this up the best we can and then grab a chamfering tool and touch the edges that we can reach with it. Yeah, that's pretty good. Okay, a little Scotch-Brite. That feels good. Let me wipe these grooves out with a paper towel, wrapped around an awl. Just so I don't have a lot of oil in there. Let's see how the belt fits. Oh yeah. That's great. Oh, I'm really happy with that. Very, very nice. Okay, so now we need to flip this around, get hold of it, and face off the material on the other side. So we're going to be grabbing the inside hub of this. However, these surfaces on the outside are going to provide support. So the cutting pressure is going to be against the ends of the jaws. So let me do a little tapping to try to make sure we have that fully seated. And I'm going to grab this pretty tight, even though I know it's going to leave some marks. Okay. Let's see what that looks like. Yeah, it doesn't look perfect. Let me grab an indicator. Okay. Let's see, so that's pushing in the most, which means this jaw over here is the one that's relaxed too far. I heard that settle. Let's see how close we are now. Go all the way around here and get all of these nice and tight. Saw that one move. Let's see where we are now. In 1,000th. So right there is the one that's in the most. You know what? I don't think I'm going to get this to run any closer than that. That is just going to have to be good enough. Okay. Let's try a different tool this time. Let's try some high-speed steel. Carbide's nice, and maybe I'll finish with it, but let's see if the high-speed steel is better for taking off a big chunk of this. A little lubricant, very little, because it's gonna fling it. Well, you see how this is going. Let me just finish this off camera and then come back when it's done. This is the same setup that we had in the mill when we made the spindle pulley. The only difference here is this is a little bit larger, so we don't need the parallels because this pulley can actually sit on the bottom of the vise and it's still up against the stop exactly the same way. Let's start by spotting the hole. Grab a little A9 here. Okay, that's spotting drill. Let's put in the tap drill. Okay, tap drill. And then finally the tap. Lots of lubrication for the tap, and we'll change gears and do this nice and slow. Tighten the check a little bit here. There we go. Now let's just put the spotting drill back in there and clean up the edge of the hole. Okay, now we just need to rotate this. Put a screw in here so we can see it easily. And then just need to rotate it 90 degrees and do it again. That looks about right to me. We've already got the spotting drill in. That looks good. Okay, I've got the screws in this now, a pair of 832 screws, and on the motor shaft and locked down. And it spins pretty straight as far as I can tell. Let me get a dial indicator here and let's see how close we got. Now this is a thousandths indicator, so every line here is a half a thou. Let's see how close we got here. That is fantastic. I'm seeing, oh, it's just over a half a thou, maybe 6/10. Could not be happier with that. Okay, well now we have a spindle locked together with a pulley on it, and we have a motor with a drive pulley on it, and we have a belt to connect them. We are just a few parts short of having a ToolPost grinder here. That's it for today. Please give me a thumbs up if you like what you're seeing and comment below. Next time, we're going to start working on the clamps and the parts to mount the motor to the spindle. Be sure to subscribe so you'll be notified when that happens. Thank you for watching.